All right, what's up, guys? In this video, I'm going to pick up some multivariable calculus. We're going to be talking about arc length again, but this time it's going to be with respect to polar curves. So it has to find the arc length of the spiral r is equal to e to the theta, between theta is equal to 0 and theta is equal to pi. So all we have to do here is just remember what the definition for arc length is going to be with respect to polar curves. So let's write that down. So with respect to a polar curve, it's just going to be L is equal to the integral from alpha to beta. And it's going to be the square root of f of theta squared plus f prime of theta squared d theta. And this is approximately equivalent to the integral from alpha to beta, the square root of r squared plus dr over d theta squared d theta. Okay, so that's the definition for arc length as it relates to a polar curve. Okay, so in our case, let's go ahead and get dr d theta. So dr d theta will be the derivative of r with respect to theta. And the reason why I introduced this way of writing the arc length is because in this case, the spiral is given to us as r is equal to e to the theta instead of f of theta is equal to e to the theta. So that's why I decided to write it that way. So keep in mind that these formulas are equivalent to each other. They're just written different ways to fit the context of the problem. Okay, so dr d theta, in this case, that's just e to the theta. Okay, that's basically asking us what the derivative with respect to theta for e to the theta is, and we know that's just e to the theta. Okay, so that's basically what it's asking us. Sorry, I'm trying to adjust the stand here. Okay, so now we go ahead and use the definition we have and take it from there. So here's what we got. So we got L is equal to the integral, and it's going to be from theta is equal to 0 to theta is equal to pi. So this is going to be from 0 to pi. And what we're going to have is the square root. And I'll write everything out. It's going to be e to the theta squared plus e to the theta squared d theta. That's what it should be when you set it up. And again, we're using this definition over here. I'm writing every step out for you to see. Okay, so let's go ahead and simplify here and see what we get. So we'll end up getting the integral from 0 to pi. And I could just basically write this as the square root of 2 times the square root of e to the 2 theta. Okay, and then d theta. That's me squaring and simplifying. Okay. Now, we know that the square root of 2 is just a constant. It's just a number. You just plug it into the calculator, it just gives you a decimal. And we also know that if we take the square root of e to the 2 theta, that's just going to give us e to the theta. Because remember, the square root of e to the 2 theta, that's basically e to the 2 theta divided by 2, which will give us just e to the theta. So the square root will go away. And we could end up factoring out the square root of 2. So I'm going to factor the square root of 2 out in front of the integral sign. So this is going to be from 0 to pi. And then what we'll have on the inside is just e to the theta d theta. Okay, so hopefully you're with me on that so far. All right, so we just got the square root of 2. We know that if we take the antiderivative e to the theta d theta, we get e to the theta. And this is going to be from 0 to pi. So when we go ahead and substitute in using the fundamental theorem of calculus, we'll get e to the pi. Remember, e to the 0 is 1, so that's going to be minus 1. So we'll have the square root of 2 times e to the pi minus 1, which we could put in a calculator and find out an approximate value for that by plugging in a calculator. So that's what I'm going to do in this case. So looks like we'll have square root of 2. And we'll multiply that by e. And we could just use x for the time being. And looks like I get approximately 31.3, which is what you should get in your calculator if you put it in with me. So this is approximately 31.3, which would effectively be your arc length. So that's your final answer. So your final answer here, when they ask us for the arc length here, the arc length for this spiral, we either know arc length with L, and we could say that, instead of saying it's equal to, we could say that it's approximately 31.3, which again is the square root of 2 times e to the pi minus 1. All right, so let me circle that for you, and that's going to be your answer. All right, so if you guys got any questions about this, please let me know. I'll be more than happy to help you. All right, I'll see you guys next time. Y'all take care.